So this tutorial is going to focus on the poly object and the poly tilde object and how to create a polyphonic instrument using Max MSP. So we're going to start with the poly object. And the poly object is designed to do voice allocation. So essentially what it does is you set it up to say, I'm going to have up to 8 voices running. And Poly will receive note on messages and note off messages, and it will basically determine which voice is free of the 8 or 12 voices, however many you've set up, which voice is free to accept a note on or basically a note on message. And it will match the note off messages with the previous note on messages. So I'm going to make a poly object here just so we can see. Let's make it, I'll just make it so it's got 4 voices. The second argument for poly is voice stealing. We're not going to deal with that just at the moment. I'm just going to connect my note in and my my pitch and my velocity into the poly object. And I'm going to put a number of integer boxes below so we can see what kind of data comes out of the poly object. So I'm just going to connect the first 3 of these. Okay. When I play a note on this keyboard, I'm going to turn my audio off so it doesn't sound. What you'll see is that Poly basically said, okay, the note on was 65, and the velocity, I can't remember what it was, 43, and then the note off, 65 and 86, and then 65 and note off. Because there's only one voice playing at a time, Poly basically says use voice 1 on this. So the first outlet of Poly tells you which voice is free. Now if I change the mode of this to, I'm just going to switch it to being a polyphonic keyboard, I can turn a note on, and then I can turn another note on, and then I can turn this note off and that note off. And you can see how Poly is saying put 60 on in voice 1, but now you want to play 62, but voice 1 is still busy, so use voice 2. And then 62 is being turned off, well that's in voice 1, and then 60 is being turned off, 62 is being turned off, that's in voice 2, and then 60 is being turned off, and that's in voice 1. So I'll put on I'll put a chord in here, that's voice 3, turn off voice 2, turn off voice 3, and turn off voice 1. So that's how Poly works. It really is just a voice allocation and then followed by the pitches and velocities that have come into the object. Okay, now I mentioned that there is voice stealing, the second argument, and I've got a value of 1 in here. When you have the second argument is 1, what Poly will do is it will, if all the voices are filled up with active notes, it will look for the voice that has been on the longest, and it will send a note off on that voice and then send a new note on. So we call that voice stealing, where even though that voice might potentially still be playing a note, we need to do something with the incoming new note, and so we steal it from the one that was playing. Okay, so in this particular setup here, I have, first of all, I'm only dealing with what I would call percussive sounds in this particular instrument. So I have an envelope that's fixed. There's no sticky point on these envelopes and final release on these envelopes. Basically, when I play a note, it's going to play for whatever duration the envelope is set to play for, and it, regardless of when the note off actually comes. So it's a sort of a simple version of a synthesis instrument here. Okay. So what happens here when I'm getting the information out of my poly object, and the information I'm getting is which voice pitch and velocity. And what I might do is I might put a message box here just so we can kind of see what happens here. Okay. What I'm doing then is I'm sending that list to the root object. And you remember that the root object takes a list as input. It checks the list against the first element of the list against the possible values that you supply in the root object. And then it will put it out and put out the remainder of the list out that outlet. In other words, if a message is coming in saying 1, 60, 100, the value 60, 100 will come out. So the pitch and velocity will come out. And this is going into a patcher called do additive. And you can see that I've simply duplicated 8 copies of this patcher and connected each one of these duplicates of do additive into a different outlet in my root object. Okay? So what we're expecting to come into do additive is a list of pitch and velocity. If I open up this, let's look at see what happens. Well, down here you see that abstraction called additive 3 with some default value. And you remember this one is capable of having a frequency put into it, and it will do additive synthesis. And if I double click that, we can see the internal workings of the patch, where the pitch comes in, it sets all the frequencies of the partials through multiplications of 2 and 3 and 4 and 5, and then it bangs this trigger, which bangs all of the envelopes, and the envelopes all control the various frequencies that we're generating. Okay, so we've looked at that already. It's also got the possibility of having vibrato coming into it. All right, so that's our do additive patch. The majority of it is actually inside this additive 3 object. So we have pitch and velocity coming in here. We unpack the pitch and the velocity. And for the velocity, we check to see whether it is 0, i.e. it's a note off, or it's non-zero, i.e. it's a note on. And right now, all we do with that information is that we open or close a gate. If it is 0, it's a note off. Then we close the gate. And if it is not 0, then we pass a 1 and we open the gate. This, of course, happens before the pitch comes down here. So we've made our decisions about whether the gate is open or closed before we pass the pitch into the gate. The pitch, if it goes through the gate, gets converted to frequency from MIDI note, goes into this object. This object puts out an audio signal as its output. And this audio signal is then attached down below into a live.gain object and then out to our speaker. Okay. Why do we have to have that gate and do additive? Well, that's because we're just doing this. We're not dealing with note offs in this particular patch, the way it's set up. We're using a strip note up here. So we're only dealing with note ons, and we're simply triggering the pitches whenever we receive a note on. However, Poly will generate note offs for us. And if Poly generates note offs, we need to make sure that we don't re-trigger another copy of the note, right? Because if we didn't do this, the note off would also come in here and trigger another note. We get a note every time we played a note on, and every time we played a note, well, every time we played a note on, and when that voice gets reused, Poly would send us a note off that we don't want. Okay. Maybe what I'll do, just to make that a little bit clearer, I'm going to print the output from Poly, just so you can see what's happening. And I'm going to move this over and put the console up, and we'll clear console so you can see. And I don't have my sound turned on yet. I just want to see what Polly generates. Okay. What Polly is generating here, you can see that Polly on voice 6 is first turning a note off, and then it's turning the new note on. And then in voice 7, it's turning the previous note off, and it's turning the new note on. Okay? And it's just walking through the root, or walking through the voices one at a time, turning the previous note off and the current note on. And that's because we've got this voice stealing happening. Okay, so there are different ways to doing this and solving this, creating a patch like this, but this is the one that I chose to do. I hope that's clear. This is really just an explanation of voice stealing and us having to make sure that in our synthesis engine, the part of the program that's actually doing the synthesis, we are ready to ignore note off messages because Polly will be generating them. Good. What else? Duration. So there is a duration control, and the duration control, there's a slider that allows us to set durations, and this value goes into each copy of the additive synthesis, comes in here, goes into the additive 3 object, and inside that basically comes in here and sets the domain for all 5 of those envelopes. Okay. And I'll just hide that because we don't need it anymore. All right, so now we can turn this on and give it a go. Those are all the notes that were hanging there while the audio system was turned off. And you'll notice something else. I put a load message -20 into my live.gain object. And that's because we have to be a little bit careful when we're playing multiple copies of this instrument, because we're not just playing a single line. We actually can play chords, and if each of those chords is playing, or each of those notes of the chord are playing at full volume, we may get a signal that's too loud. So I'm just scaled this down to -20 so that it's not going to be too loud coming out. All right, I think this is all set to go. Let's put our duration at, well, 980 is good. So just before I play this instrument, this is what I would call a percussive instrument. So when I trigger a note on, a message gets sent, and it triggers that sound and basically plays to the end of the envelope. And to ensure that I don't get clipping, the next note will just always play on the next voice, basically the next copy, and the next copy, and the next copy. So if I play a note here, maybe well, and if I'm going to switch modes here. I'm going to go back in here. I know you can't quite see this, but I'm going to switch it to touch screen again. You can see these flashing, and you can hear the notes are overlapping one another. But because they're being played by different synthesis engines, each of these being a separate synthesis engine, we don't get clicks. I can make the duration longer. And as long as I don't have more than 8 of them playing at a time, I don't have a problem. If I do get more than 8 playing at a time, you'll start to hear that I get clicks. I don't know if you can hear there were some clicks in there. And that happens sometimes when you're starting a new note before the previous note is finished. Okay, and I can have very long durations, 10-second durations. And of course, the durations are only going to be affected when I play a new note. So let's put some really short durations. And similarly, I could play on my keyboard because I've got a note in hooked here, and I'm going to make the duration longer. Right? And I'm not getting any clicks, and I've got complete polyphony going on here. Okay, so that is how to use the poly object. And when I'm using the poly object in this way, I basically am just routing the incoming data to multiple copies of my synthesis engine. And if I change this to a poly 12 because I want to have more voices, then I've got to have a route that goes up to 12, and I've got to add 4 more copies of this and connect everything up, which can be a little bit of a pain. Now, just if I wanted to set this up so that I could deal with note ons and note offs, then I would take away this voice stealing. I would take away the strip note because I want to deal with both the note on messages and the note off messages. And then I'd pass both the note ons and the note offs into this. And inside this object, I would have to send messages. If it's a note off message, I would have to send somehow like a next message into this synthesis engine to deal with the last component of my envelope, right? So as we talked about earlier in the week, there are really 2 fundamental designs for envelopes. One which is a percussive envelope, the one we have here, and one in which the second last point is a sticky point, and we run through the envelope until we get to that point, and we wait for a note off, and on the note off, we do the last segment to turn the note off. And that would be triggered by a note off message. So this could be, it could be done here, as well as just selecting an open. We would no longer, we actually could still keep the gate, but we would have to send the note off message. When we get a 0, we'd have to send something into this, and that patch would have to be configured properly. So there would be a fair bit of work to doing that, but it's certainly possible. Remove the strip note, take off the voice stealing because we no longer really need the voice stealing, and then inside the object, we would deal with the note off message triggering that next. All right, so let's close this up. I'm not going to save it. And let's open up the week 8.4, which is dealing with the poly tilde object. Okay, now poly tilde is kind of a conceptually complicated object. But you can see already in this patch that this is much, much simpler. What the poly tilde object does is it takes an argument which is the synthesis engine that is going to be used for the polyphonic allocation and rendering of notes. Okay, and then it takes a polyphony size. So this is a polyphony of 12, meaning we can have up to 12 voices running at any given time. What actually happens in poly tilde is that in memory, not sort of visibly out here as patches, but in memory, it has created 12 copies of this do additive poly patch. So I'm going to double click on this so we can see what it looks like. This is the do additive poly patch. And you can see that it's quite similar to the last patch. But rather than having inlets, it's actually got an object called in and then a number. So it's got an in1 and an in2, and then it's got an out tilde 1. What that means is that some non-signal message comes in here. It happens to be a list. And some non-signal message data comes in here. This happens to be the envelope duration. And the output is a signal output. So it says out tilde 1. It's going to be a signal. Okay? So if this were just out 1, it would be a non-signal. And it obviously wouldn't work. Okay. So that's the do additive poly. This is like an abstraction. It exists separately. In other words, I've made this patch, and you can download it separately. And I've made it exactly like this, as like it is an abstraction. I've saved it in my folder so I can access it. Okay? And it's basically, other than the fact that it's been turned into an object to use with poly tilde, it's essentially the same as the last one we looked at. Okay. If you don't do this in and out, then this will not work within poly. Okay, so in a sense, what we've done is we've encapsulated this code inside the poly tilde, and the poly tilde object is going to look after the voice allocation all by itself. So we don't need to create lots and lots of copies. And all we're doing is we are going to use a counter which runs between 1 and 12, and we're going to send in a target message, target $1, into the poly. And that happens before we receive the pitch and the velocity. So when we pack the pitch and velocity together, we first bang the counter, we next bang the duration value, which goes into the right inlet of the poly, and then we send the list into the poly. The counter has already banged the target, so we've said which copy of the poly object do we want to send this data to. And it basically says 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, then back to 1, 2, 3, and so on. And this works. So the sound is on. And you can see the counter moving. And make a long duration. Okay, so it's working fine, and similarly I can play this on my keyboard. I don't have my keyboard hooked into this one. There we go. This keyboard is not set up for polyphony. So it's set to monophonic. I'm going to set it up to polyphonic so I can make the duration a little longer. Now, I'm not doing anything with velocity at this point. This is really just a simple example of the poly tilde. you're welcome. You should be taking the velocity inside here. By the way, when I double click on that, I'm going to do that again. I double click on this. In actual fact, I am looking at one of the instances of this. If I look at the top, it says do additive poly, and in brackets it says 9. This is actually opening up the 9th copy of this. If I send another node in and then do this, I'm looking at the 10th copy of this. So I've got both the 9th and the 10th. And if I kept doing this, you would discover that there are actually 12 copies of this that are available for me to look at. They all look the same, so it doesn't really do me any good to look at all the copies of it. But just to show you that these are actually separate, right? And that's why this has its own set of envelopes, and this has its own set of envelopes, and that's why the voices don't cut each other off. Okay, now within the poly-tilde world, there are some somewhat complicated ways of dealing with note-ons and note-offs. There's something called the note message that you can pass to it. If you want to deal with properly with note-on and off messages, you can also use a MIDI format to format messages, and then inside your object you can parse those messages. All that is rather complex. And I'm not going to go into it in our tutorials, but if you look at the poly help files, I'm going to just bring up the poly help files. You can see in this example that they're using the note message. So basically that sends a message into poly telling it that this is a MIDI note. And if I double click on this to look inside it, you'll also see a particular format that is used often with poly, and that is inside the poly. You'll also see the in one and the out tilde one that we had, but there's also a this poly tilde message, and you can send messages into, it means this copy of the poly can be set to be muted and turned off, or not muted and turned on. And so basically what happens is that this information is used so that the poly tilde object, the main poly tilde object, knows whether this voice is free or not. So in this little simple patch, a pitch comes in, it's converted from MIDI to frequency, it drives a sine wave, and this is another form of envelope. It's an envelope generator. And once the line, so this plays, and when the note starts, it sends this message saying, this particular copy of poly is not muted, and 1 meaning it's on, it's turned on. And then it starts the envelope. And when the envelope line is done, and essentially the note is finished, a message comes in here and says, actually mute this voice, and it will inform this poly that 0 meaning it's off. And if you do this, then your poly object will know that this particular object is, this particular copy of the poly object is free to be used. Okay, so that's another way of working with poly. And you're welcome to use this mechanism if you want. You can also look at some of the other parts of poly if you want to. It's not necessary to do that if you're dealing with these sort of simple percussive instruments, because we're basically running on the assumption that if we've got 12 voices, unless we're playing 12 or 13 note chords and overlapping them, we're not going to have problems with our voice allocation. Okay, so I just wanted to point that out, that there are other ways of working with poly. This is sort of the simple way of working with poly. All we're doing is we're targeting sequentially each of the voices in order, and 99 times out of 100, this is going to work perfectly fine for the kind of synthesis we're doing here. Okay, so that's poly tilde. Just to recapitulate, the sort of concept of polytilde. It has internally, it makes reference to a separate patch which has been created and saved into your folder with a name, and it will create however many copies of that particular patch you designate as your second argument. 12, 16, 32. You know, they don't take up that much memory. Having 32 voices is not really going to be a problem. And then you can specify which copy of those 12 or 32 copies of this particular patch you want to direct your message to. You must do that before you send in the message, though. All right? Don't send the message in and then target it. If you want to send a message to all copies of I'll say all 32 copies or all 12 copies of this object, this do additive poly, you can target 0 and then send a message and it will go to all of them. Okay? So there may be times when you want to, just pass a message to all the objects. Maybe you're updating the envelopes, or maybe you want to alter the duration of the note and you want to do it globally. That's the way that you can do that. Okay, so I think that should get you going on the upcoming assignment. You can use this as a kind of simple model, and then you can expand it and figure out how you're going to do timbral changes with velocities and so on. Thank you.